welcome. In this lecture, so in the previous lecture, we talked about how one gets a slope field, right? So I drew this already for you. This is the slope field that one gets from this particular differential equation. So for each point I would have only needed to put in x. It doesn't actually depend on y, which is why if I had drawn this properly, each of these slopes would look the same, each of these would, and so on. But now what we're going to do from this is that if we actually kind of traced through, we would get, so this differential equation, the solution is, so here, let me just write this here. So following, let's do this with blue, which was my original thing I thought I would do. So following the slope field gives back, the slope field gives back solutions y equals minus x squared divided by 2 plus c. Okay? So let's kind of look at what I mean by that, right? Because these are solutions to this differential equation. So when I say solutions, I mean solutions to this differential equation. And you can check, right? How do I check that this is a solution to this differential equation? Actually, let's just do this over here. So check that y equals minus x squared plus c is in fact a solution. Right. What I want to do is I want to take the derivative with respect to x of both sides. So I'll take d dx of this side, so y. In theory, this should end up equaling, this is a question mark, and then we want d dx of this side. So let's see. Right, so on this side, we do indeed, this gives us dy dx, so that's exactly what we want. And then on this side, we do get, so the 2 comes down, it cancels with that, so we get minus x, and then we take the derivative of c, so we get c. Okay, so this does like that. Okay, perfect. So this is a solution. And then if you actually kind of see, so if I had done this really well, and I kind of followed my slope lines, I need some more slope lines in there. So they should kind of, they should kind of be tangent here. And they should be, tangent as you go along. So maybe this needs to go out a little bit more to actually kind of make this work properly. But you can kind of see it's kind of tangent to there. It's kind of tangent to there. And then if I started in a different place, I would get, right, another solution, right? Because there's a family of solutions to the differential equation. You get one for each c value. So I could keep on doing these, and right, I'd actually get infinitely many of them, right? And basically one for, not basically, I would get one for each possible c value. Okay, and these are actually the solutions. And again, what they do is they follow along the slope field. So the slope field should always be tangent to them. So it's a kind of way to see what the solutions would actually look like. Okay, so I know this is a quick one, but I hope that made a little sense. This is a very pretty picture, and I will see you in the next lecture.